In this problem, we'll focus on taking the antiderivative of the arctangent of 1 over x, without focusing on the 7 that's in front or plugging in the boundaries of 1 and the square root of 3. Since we don't know the antiderivative of arctangent, we're going to take an approach with some substitution using trig functions. Suppose that we let theta be equal to the arctangent of 1 over x. Arctangent of 1 over x means draw me an angle whose tangent is 1 over x. So we'll go ahead and draw that angle as part of a right triangle. The tangent, being the opposite side over the adjacent side, is 1 over x. So the opposite side is 1 and the adjacent side is x. We can also note at this time that the cotangent of that theta is going to be the adjacent side over the opposite side, which is x over 1, or just x. That's helpful to us because in the process of substituting, we want to know what dx is. The derivative of cotangent of theta is negative cosecant squared of theta d theta, and now we have enough to be able to fully plug into our original integral. The arctangent is replaced with theta, the dx is replaced with the negative cosecant squared of theta, and we're ready to proceed from here. Because we have two functions being multiplied together, we can do integration by parts, which says that u times a function dv can be rewritten as u times v minus the integral of v times du. In this problem, we'll let u be equal to the first function of theta, and dv be the rest of the integral, which is negative cosecant squared of theta. To fill in to the integration by parts formula, we need the derivative of u, which is d theta, and the antiderivative of dv, which is just cotangent of theta. Putting these into the integration by parts formula, we have that u, which is theta, times v, which is the cotangent of theta, minus the integral of v times du, which is the cotangent of theta, times d theta. Now we simply need to take that antiderivative of cotangent. And it's a fact that the antiderivative of cotangent is the natural log of the sine of theta in this case. We put the plus c on the end, and we're ready to substitute back in. We will want to make a quick note that the hypotenuse of our triangle, using the Pythagorean theorem, is 1 plus x squared. This is because we'll need to know the sine of theta when we substitute back in. Since theta was equal to the arctangent of 1 over x, and the cotangent we'd previously found was equal to x, we subtract the natural log of the sine of theta, which is the opposite over the hypotenuse, 1 over the square root of 1 plus x squared, plus c, giving us the antiderivative that we were attempting to find.